So the option part of 8th question, how do you convert phenol to toluene? So phenol, first we will treat phenol with zinc dust. It will form ZNO as a product and we will get benzene. Now we will perform acetylation and we will finally get toluene. The second conversion, formaldehyde to ethanol. So this, we take formaldehyde and treat it with methyl magnesium halide. So here so this would be the intermediate step when formaldehyde is treated with the methyl magnesium halide. So here the intermediate step would be formed and we will finally get ethanol. And so finally we converted formaldehyde to ethanol. So the ninth question is, when a coordination compound NiCl2.6H2O is mixed with silver nitrate AgNO3, 2 moles of AgCl are precipitated out per mole of compound. We have to write the structural formula of the complex and IUPAC name of complex. So clearly, when 2 moles of AgCl are being precipitated out, 2 moles of chlorine atom should be free. So the structural formula of the compound is this. And now the IUPAC name of this. So IUPAC name would be hexaamine nickel 2 chloride. Nickel is in +2 oxidation state and we have 6 water molecules. So hexaamine nickel 2 chloride is the IUPAC name of this complex. So the next question is, for this reaction 2NH3 in presence of platinum gives nitrogen gas and hydrogen gas and rate equals to K. So we have to find the order and molecularity of this reaction. So since rate is a constant and it is not dependent on the concentration of ammonia, clearly it is a zero order reaction. And molecularity of this reaction should be clearly 2. Now, the unit of K. So since the unit of rate is mole liter inverse second inverse, mole per liter per second, so the unit of K and unit of rate should be same. So this is the unit of K, mole per liter per second. Write the major mono-halo product in each of the following reactions. So first part is this plus Br2 in UV light. So the main product is one two So when this is reacted with bromine gas in UV light, the double bond breaks and we get two halogens, two bromine atoms, and the product is 1,2-dibromocyclohexane. The second part of this question, when 3-phenylpropene is reacted with hydrogen bromide in peroxide. So the major product of this reaction is 1-bromo-3-phenylpropane. So in peroxide with hydrogen bromide, the bromine atom which is attached on breaking of this double bond is on the farther side. The third reaction, this is the reactant. When this is reacted with hydrogen chloride and heated, the main product formed is so the hydroxide group is replaced by chlorine group, and the product is 2-chloro-methyl-phenol. So the product formed is 2-chloro-methyl-phenol. So the next question is, an element crystallizes in a FCC lattice with cell edge as 400 picometer and the density of the element is 7 gram per centimeter cube. How many atoms are present in 280 gram of the element? So we have the cell edge as 400 picometer. So volume of unit cell equals to AQ, that is 400 picometer cube. So it is 64 into 10 raised to the minus 24 centimeter cube. So the volume of unit cell we can find out from the cell edge, and it comes out to be 64 into 10 raised to the minus 24 centimeter cube. Now, since we know the density of element, we can know the volume of 208 gram of the element. So volume of 280 gram of this element equals to mass divided by density. So that is 280 divided by 7 gram per centimeter. So it comes out to be 29.71 centimeter cube. Sorry, this is 208 gram. The question asked about 208 gram of the element. So the volume of 208 gram of this element is 208 by 7, that is 29.71 centimeter cube. Now since we know the volume of the unit cell and we also know the volume of 208 gram of this element, so we can calculate the number of unit cells in this volume. So that would be equals to volume of this divided by volume of 1 unit cell. That is 29.71 centimeter cube over volume of 1 unit cell is 64 into 10 raised to the power minus 24 centimeter cube. So the number of unit cells in the volume come out to be 0.46 into 10 raised to the power 24. Now, as we know that in an FCC lattice, each FCC unit cell contains 4 atoms. We know it. So, therefore, total number of atoms in this 208 gram should be 4 into the number of atoms in this. So, since we had to find the number of atoms present in 208 gram of this element, into number of unit cells into number of atoms in each unit cell, that is 0.46 into 10 raised to the power 24 into 4. So that comes out to be 1.84 into 10 raised to the power 24 atom. So we find out that in 208 gram of this element, we have 1.84 into 10 raised to the power 24 atoms. So the next question, give reasons for the following. The first part is, protonation of phenols is difficult whereas ethanol easily undergoes protonation. So this is because in phenol the valence electrons of oxygen atom, they are delocalized. They are delocalized in this ring. So they are not freely available for protonation. Whereas in alcohol or say ethanol, the lone pair, the electrons, are not localized. So they are easily available for protonation. So the second part is, boiling point of ethanol is higher than that of dimethyl ether. So we all know that in ethanol, there is hydrogen bonding. So between two ethanol molecules, hydrogen bonding is present. So in ethanol, intermolecular forces are prevalent. So there are intermolecular forces in ethanol and hence the boiling point is high. Whereas in dimethyl ether, there is no hydrogen bonding. So there is no intermolecular attractive forces, and hence they do not have that high boiling point as ethanol because of hydrogen bonding.